start it up. Okay, so if you go to the Canvas site, I know my Canvas screen looks a little different than yours. Okay, cool. Oh, start putting up my courses for next semester. All right. Oops, wrong. I actually uploaded all of I had kind of a bad uploading. I uploaded all the stuff to the wrong course first, and then I took it down and uploaded it to the right course. Okay, so last week, right here, if you go to the lab, there is a, I replaced the entire lab, not just the model. So this version of the lab is the lab before anything's done, and this version of the lab has the model in it, the one that we're going to continue on today. So if you downloaded that, you would get this, because all I did was zip it up and uploaded it. Either way, you could take off from where you were at. If your model ran and it worked, you could take off from where you were. If your model didn't run and you don't want to spend the time on it right now, you're free to use the version that I uploaded. Okay? All right.
Dr. Ray.
Yeah.
So you're saying that EX10 is, I'm behind as is, so when I start this lab, I need to just download the second one there, the Windows.
If you download the second one, it already includes this model that we built last week. Yeah. So yeah, there's no problem using it. You're not gonna get points off. I am gonna pull up that lab real quick. Oh, I think.
So if I were working from the beginning, just start with EX10.
Yeah, if you want to work it from the beginning, but you're going to have to build this model anyway. And the lab doesn't really the lab itself doesn't really go over every step in the creation of this model. And you were here last week. No, wait.
No.
Yeah,
Last Wednesday.
Yeah, you were here last week. Okay, so one of the things that happened last week is as we were going through the lab, I thought I was going to do something one way, but I ended up doing it a different way. And there often is more than one way to what a cliche is, skin a cat or whatever. Anyway, let's go over really quick what this model does, because it actually looks kind of complicated, but remember, it's actually not that complicated, right? It's got 1, 2, 3, 4 tools that are just adding a new field to a table. Easy. And it's got 1, 2, 3, 4 tools that are just calculating values into those fields. So those are everybody's added fields and calculated values. Right? This is the kind of raster operation right here. So the goal of this operation is to create a surface. We'll call it a modeled kudzu surface. Okay? And then compare it to the actual kudzu surface. So that's what this part does right here. So there's a raster calculator expression, and the thing that it does is create that. It runs the simple kudzu prediction model. It's not a very complex kudzu prediction model. It just says it takes 3 cutoffs: a temperature cutoff, precipitation cutoff, and a frost-free days cutoff. These are from 3 different raster data sets. And it says that this model uses multiplication. So it says that the extent of kudzu has to meet each of these three criteria, because everything in these data sets are zeros and ones. So multiply them together. Kudzu can only exist where they all are equal to 1. It's a simple model. Those are the three inputs. It multiplies them together. So at the end, we get zeros where no kudzu is predicted, and we get ones where we predict kudzu. So ones and zeros. That's the result of this. The mod kudzu raster contains zeros and ones where we've got a prediction and a result. I don't know if I kept the... I don't even know where the data is. Let's see where it is. Let's look at the output. SA Lab 10. So C, temp, SA Lab 10, calibration. So right now, I haven't run that model. I could run that model again and then create that data set. Just as a kind of a review here. Add the data, mod kudzu. So there's two data sets that I'm showing here. This is the modeled extent of the kudzu, and this here is the actual extent of kudzu. So there's two values. All right, this one, what it does here is it simply multiplies the modeled kudzu with the the actual kudzu with the modeled kudzu. We multiply those together. So what do we get when we multiply, or we add them together, sorry, not multiply. We add those two together. So what do we get in the result? Why did we add them together? Anybody remember from last week? Exactly. We got zeros, ones, and twos. And remember what zeros, ones, and twos meant? What does a zero mean? Yes. They were both were what though? They both didn't have kudzu. Yeah. Because zero means no kudzu. 0 plus 0 is 0. So they agreed that there was kudzu. All right? What does 1 mean? Actually, let's move to 2 first. What does 2 mean? They both had kudzu. They both agreed that they had kudzu. 1 plus 1 is 2. All right. So now, what does 1 mean? 1 in the result. Right. Only one model had kudzu. Exactly. Growth was the last week. Maybe I should have reversed the order of these two labs, but we're not talking about growth today. Ashley was exactly right. Anytime you see a 1, it means that the model didn't agree with reality. It either overpredicted or underpredicted. They'll both get 1. 0 plus 1 is 1. 1 plus 0 is 1. Okay? So, we're going to get a raster that has the values of 0, 1, and 2. Okay? And we're interested in how accurate the model is. So what we can do is, we talked about calculating accuracy. To calculate accuracy, it's just the number accurate divided by the total number. And the table itself had 3 fields. So whenever we calculate I'm just going to go ahead and do the plus because that's the next step in the model. Okay. Spatial analysis, tools, math, plus. So we add mod kudzu, and we add the USA. We're going to add them together. It doesn't really matter where they're stored for now. This is the next step that the model runs for us. It creates a new data set is that has those zeros, ones, and twos in it. Surprisingly, am I having the same problem that I had last week? I think I am. Nope, it's going to run. Just took a little while. All right, so ones, both of the models agree. Twos, both of the models agree. Ones, the green, it was either an over prediction or an under prediction. And zeros, both of the models agree. Since there are only 3 values, we get an attribute table. Right there is the attribute table. So the percent accuracy is 8194 plus 2654. Those are the accurate, divided by all 3, the sum of all 3. That's the percent accuracy. Okay? So last week we kind of brainstormed. I thought in order to kind of come up with that number automatically, it would be easiest to simply to select out the inaccurate. But then you'd still have to do an addition problem. It's actually easier to select out and keep just the inaccurate, not keep the accurate, because the total accurate can be derived from the inaccurate. The total minus the accurate is the inaccurate, or the total minus the inaccurate is the accurate. Okay? So, that's the next thing we did in the model. There it is. That's the next thing we did in the model was to say, okay, we want to select just the inaccurate record and create a new table with just those inaccurate values. Okay? And then all we did was we added a bunch of fields on. And those fields are going to help us to keep track of all the times we run it. So I am going to right now save this, X this out, and attempt to run the model the way it stands, which is right here. I'm gonna close mod code zoo too, because I don't know if that'll cause it to freak out. All right, so now I've got all these, and I'll leave them the same. I'll run it, and hopefully it doesn't have a problem overwriting those data sets that I just already created. If not, it'll show a little error, and you might have to go delete those. All right. Yeah. You can't add anything to your model? Huh. Okay. So anyway, that's the output of the model. Not working, it's not running. Now, did you download the one that I did, or yours was the last one? Yeah. I would just download the one that. All right, so this is where we left it. And now here we can see the value that we ran for temperature, precipitation, and FFD. And then this is the percent accurate. So it all got calculated inside of that model. I can close this and try to run the model again with the nice thing about a model, that's one of the neat things about a model, is I can close it. I don't know, how did that get way over there? Okay. I can run it again with different values and see if I can get a more accurate prediction. 130, run it. Hopefully it allows me to overwrite it. Okay, it ran it. Now I can look at the accuracy table and I get a different value. See how FFD is stored. The new FFD is stored. The percent accuracy is stored. All right. So, where we left it was that we were going to use this model and an iterator in order to change each of these three values systematically and get a different accuracy table. Now, I told you that you can only have one iterator. So, one option is to just iterate over one value at a time. But that doesn't really let us see everything. It'd be nice if we could iterate over multiple values at one time. I always like to do my iteration in a different model. So I'm going to save this guy and then create another model, new model called, I'm going to close it down. I'm going to rename it. I'm going to call it kudzu calibration. Sometimes it if you really wanted to name it something, you go into properties and change both those. Okay, so I'm going to edit it. Now my kudzu calibration model, I'm going to iterate it lots of times. I need to figure out how to iterate over multiple values. We don't want this to run all day, so I think that maybe five of each is fine. So we'll check 5 different FFD values, 5 different five different precipitation values, and 5 different temperature values. We want to check all the different combinations. So it's like 5 times 5 times 5. So really, we're running the model 25 times 5, 125 times, right? So you can see why Model Builder, it's kind of neat that we're running Model Builder rather than manually entering in those values 125 different times. All right, so last week's assignment was to look at the model-only files, and one of them, model-only tools, was collect values. We won't need that until the end. We'll need collect values when it goes to run. Okay? But we will need we'll need to do an iterator before then. Did anybody think about or attempt to come up with a way that we might be able to iterate over these 3 values at the same time by reading through the iterators? Okay, so field values is right here. I don't know if there's one right answer. Okay. Let's see what field values does. By the way, field values is how I yes. So it is the way that I thought of, but I was interested in seeing if any. I didn't tell you that last week, so that's good. But if anybody has a better idea, that'd be awesome too. But yeah, field values is the way I thought it might work. So field values, though, is going to require a teeny bit of Python in order to get it to work, at least the way that it worked for me. Okay, so the output of the tool is a variable called value. The value contains the value of a field. Okay? So what it does is it allows us to go through a table and look at all of the values in one field. So here's the field for iteration, and the data type. Okay. So let's open up Excel because we can create a table in Excel that we can iterate through. Okay. You could also do it in, well, you could do it in pretty much any, like you could do it in Notepad++ if you wanted to. But it might be a little bit easier in Excel. I think it's going to be easier in Excel. So let's think about this for a second. Spreadsheets are kind of powerful but basic tools. We need to iterate through frost-free days, temp, and precip, right? However, we're only allowed to get one field's values. For once it wasn't me, I guess. Okay, so let's call that final field. Let's just call it value or something. Okay. So we need to iterate through frost-free days, temperature, precip, but we're actually only going to be able to get one value. Before we worry about that, let's worry about this. Okay. All right. So, what are all the frost-free days that we want to? I said let's check 5 frost-free days. So let's kind of like buffer around those frost-free days that we came up with last week, which was 145. So we can come up with any numbers we want because what we'll do is we'll run it and we'll see if a very good prediction came about. And if it's on the edge of the prediction space, we could run it again. But let's just worry about it being there. So I'm going to say 145 is going to be our central value. And let's go every 5. Maybe, I don't know. You guys want to go every 5 or every 10 out 2 in each direction? 10? Okay. That's probably safer. I like that. We did 5 last time I taught this. But let's do... so that would be 165, 155, 145, 135, and 125. Those would be the values that we want to check. I don't know why I did them in that order, but I did. Okay? Yeah. Yeah. So value is actually going to be a combination of this one, and this one, because we can only get one. And then to split them back apart, we're going to have to use just one line of Python. They found somebody down there. Thanks, Kevin. It was on there. I appreciate it. Sorry, I should have sent a message to him. Okay. So we have to do the same thing with temperature and precipitation. So let's come up with the temperature values that we want to test. those would be 10. We're not, it doesn't seem like there's as much variability here. So we might even consider going by ones, but maybe let's go by twos. So 10, 12, 14, and then 6, 8, 10. Yeah. So let's just write those down. 6, 8, 10, 12, 14. And then finally precipitation. Now precipitation looks like it's a pretty big number. So maybe, I don't know, go by hundreds, maybe even 200s. What do you all think? 200s? Okay, so let's go by 200s. And put this one in the middle. I'm not that good at subtraction. So what is that, 2,900? And then 2,700, is that right? And then 3,300 and 3,400, or no, 3,500. So those are the different values that we want to check. We want to check every single possible combination. Now we could write a little program that would spit these out into a file for you, but it's not a programming class. So right now, what we're going to do, we know that there's going to be 125 different choices, right? So what we can do is trying to think of the best way to do this. First thing I'm going to do is reverse these. 125, 135, 145, just because it's bothering me. 165, okay. All right. So really, with one of these, we could just repeat over and over and over. So we could go like this, right? So we're repeating that value. And in fact, 1, 2, 3, 4, 5. Okay, so I did it 5 times. Now I can, I'm going to insert a new row here and call this precip. Now I can type in 6 and just go all the way down. Because all those will have a value of 6. Is that? So each of those gets, no, sorry. That's the final one. So 6 for these, 8 for these, and then 10, 1, 2, 3, 4, 5. Now, Excel is actually pretty good at figuring out patterns. So I did the 6, 8, and the 10. I can just copy, and then when I go fill down, it didn't figure out the pattern. Sorry. Okay, 1, 2, 3, 4, 5. 12, 12, 12, 12, 12. That's 1, 2, 3, 4, 5. And then finally 14, 2, 3, 4, 5. Okay. So that's kind of oscillating on that pattern. And that represents all of the different possibilities between just these two data sets, right? 125 and 6, 125 and 8, 125 and 8, 10, 125 and 12, right? So now we can add another field in here and value. We can do this for 2700 and just fill all those down with 2700s. Yep, that'll be all. So this represents one block now. So now we just take this whole block and copy it 5 times, and we only have to change oh sorry, this should be temp. Or no. This should be temp. This should be preset. So now we only have to change this column's values when copy and paste. So I'll go like this. Control C, Control V. Go to the first one and change it to 2099 or 20900, and then just copy over all the 270 values. I do that again, except for I change it to 3100 and copy down. One more time. Change it to 3300. Copy down. Did I do that right? Is there one more? Yeah, 3500. One more time. 3500. Copy down. All right. So, it's kind of messy, but now I'm going to delete these 2 tables again. It's kind of messy, but now I have every single possible combination between these 3 values. So what I'm going to do right now is upload this to Canvas when I finish. So don't worry if it doesn't all work. All right. So the final thing that I need to do is combine all 3 of these into a single field so that there's only one value, because we can only iterate through one of these values, not all 3 of them. So what I'm going to do, this is something that you may not have learned or you might have learned. So I'm going to say it's FFD plus, so I said equals FFD plus, and I'm going to put a little underscore plus this, and a little underscore plus this guy, and then that'll be all I need. Oh, I forgot in Excel it's not, it's and, not plus, because it's Visual Basic based. Python would be plus, and okay, so now the result is this numbers delineated by an underscore. Really, we can choose any character we want to delineate. It's an underscore. Yeah, it's an underscore, not just a space. We could actually use a space, but I didn't. Another character I like to use a lot is this pipe. Either way. Yeah, let's change it to the pipes. Okay. And then what I'm going to do is fill this down. Hold on to the corner, fill it all the way down, and we'll have our table that we want to manipulate. All right. Right. I'm going to export this now, and then I'm going to upload it to Canvas, and so we'll all have it in case you didn't get everything. So I'm going to go File, Save As. Actually, there's an export. Nope. I'm just going to go Save As, and save it in. Doesn't really matter too much. Let me put it in where I've been working. C temp essay, and then lab 10. But I'm going to change the file type to comma delimited. That's the format that ArcGIS likes the best out of all. So comma delimited CSV. Change it to that, and we're going to call it values.csv. I'm going to close it up. And then I'm going to go to the same place. Temp. The other thing that I have to do is that for some reason, Excel likes to call them CSVs, but ArcGIS wants them to be called .txt. So I got to change the name to a TXT. Yep. And the way that if you don't see the extensions on your files, you can go to View and where is it? Hide file name extensions. Make sure that's checked. So you don't want that hidden. All right. You don't have to do this yet unless you want to. I'm going to check to make sure that that it works. See, before I upload it, and then I'll upload it. C10. Let's say Lab 10 values. Open. Yep. Okay. It works great. See, I've got those values now. FFD, temp, precipitation value. We're all set. We've got our data. Okay. All right. So, for those of you who want to make sure, like that, maybe you haven't used Excel before and I went too fast, I'm going to also put that in Lab 10 as another link. Yes, I'll do that in a second. Table for, okay, I'll do that. It'll take a second to upload, so I can do that while it's uploading. Upload, choose file, values, upload. Okay. Oh, it didn't take a second to upload, but I'll still go back. So here is, oh, I already got rid of it. I'll show you the formula again. Oh, here, I'll just do it in a new one. So this is the formula. Equals this column, then you have to do plus, and then quote, type, quote, plus, then this one, then plus, quote, type, quote, plus, then this one. So that's the formula. That'll work. So this means that it's a string. This means that it's a string. Oh, it's not plus, remember? It's and. Oh, sorry. So that's the formula right there. No pluses, just ands. Okay? All right. I'll just leave this up because there's no reason to close it. Okay. So now that we've added that, and in case you didn't add it, just go to Add Layers and hit Values.txt. Add it to there. Actually, you could add it there if you want, but let's actually navigate to, we're going to go to the input table, and we're going to, instead of choosing that table, we're going to actually navigate to where it is on disk. So choose values.txt, add it, and then choose the field. Notice that it lets you choose FFD, temp, precip, or value, and choose value. Leave it as a string because it's a mix of numbers and characters. So if you say that it's a number, it'll freak out. I'm going to leave it there for a second in case any of you had trouble downloading the file for a second. You download the file wherever you put it. That is this one right here. Okay. Then the field is value. Data type is string. You These values, I don't know what that does. Iteration values is based, okay. So if your field had multiple different values that were the same, like, you know, it wouldn't repeat that. It would say, oh, I already did this value. We made it so that all of our fields are unique. It is possible. Okay, so then we're gonna hit OK. Is that okay if I hit OK now? No?
Yes.
Oh, yes. Okay. All right. So this is the input value, right? That's the field. And then that's the output value. So we're going to rename this guy. I'm going to rename it comp value because just value makes me confuse it with this one. It's really I'm calling it comp value because it's the composite value. If I were to run this entire model, it would run over every single value. So it's running 125 times. All right. We don't need it to run 125 times yet, but it's good. So notice that the last value that ran was 165,8,350. That should be the last row in our table, the 3,500. I think it is. So what we need to do is we need to create 3 integer values. Actually, we don't need to do that because we should do that. Well, so our kudzu calibration, let's drag that on. Oops, kudzu prediction, sorry. Kudzu prediction. And notice that we have 3 parameters that we can add: temp min, FFD min, and precip min. Temp min, make variable, FFD min, and then finally precip min. So now we've got all 3 of these data sets out there ready to run. See what I'm saying? These are the 3 values, and we want to feed this into that. And this is where I told you it's going to take a little bit of Python. I can't find a way not to be able to connect these up into here. So these values need to get into here, but they need to be values. This isn't going to accept like if we just wrote percent comp value percent, we need just part of those piped values. So that's not going to work to just do that. Anybody remember what tool allows us to calculate a value? We did it before. We didn't do the same exact thing. But let's right click here, and there's actually a tool called Calculate Values. It's a model only tool. And it allows us to run a little Python script. Okay? We can use it in there. So we're gonna do that. There's our little Calculate Values guy. And we're actually gonna have to delete these 3. I just pulled them out for fun, but because this is going to be the input for those 3. Well, one of the inputs. So let's go ahead and rename this. The output value is going to be precip here. I'm going to go ahead and delete these guys for now. So delete those little guys that are hanging off, because this is going to go into there. So let's calculate a value. Right? This is the expression. Remember, if you can fit it on one line, you can use the expression. If you can't fit it on one line and you have to do some logic, it has to go down here. This is the data type. They're all going to be long integers, so we'll change this to long integer. Now this is long. This expression, I'm pretty sure we're going to be able to do it in one line. So it is percent comp value percent comp value percent, okay? And then we need to do dot split, and then a pipe. Quote, pipe, quote. So what this is saying is split up the comp value at the pipe. Okay? And then we want, is precip first, second, or third? It's the last one, I think. So we want to, because they're indexed 0, 1, and 2. So what this is saying is take the composite value, split it at the pipes, and take the third value, because 0 is the first value, 1 is the second, 3 is the third. These are brackets. Bracket, bracket, those are brackets. Split is case sensitive, don't capitalize it. What? A dot before split, yep. All right, I'm gonna see if this. Okay, my syntax doesn't work. That should be a string. Maybe, let me experiment a few times. I'm sorry, I was working on today's lab too much. Make sure, let me see if this works. Zero, 1, 2. Split it at the pipe. You know what? I think I'm getting my computer programming languages mixed up again. Hold on. I think in Python, no. Alphabet, is this, that is right. URL.split. Just a second. All right, so I've got a list that looks kind of, a data set that looks kind of like this. Right. Let's say A equals A dot split. That's exactly what I'm trying to do. Something's not working right. Hold on a second. String. I don't know why it would matter if they were underscores. Oh yeah. second, I got this little extra. Okay. It is treating this like a string, I guess. str. I don't know. It's not running still, so. Okay, so that worked. Let's see if this works. That's not actually splitting it up though, is it? That's weird, so. What's that? 3501. Yeah. Value equals 3501. I don't know what's going on. Dang it. String dot split. I may just have to not try to do this in one line of code. The list index is out of range. All right. Okay. So, okay. I know what's happening, right? Okay. So what's happening is that anytime it sees a function, it automatically assumes that that function is in the code block. And so it's attempting to run it there. So we need to, it's got this function right here. We're going to have to do it as a code block. I thought I could align, but it won't work. So, what's that? Comp value? Yeah, because it's trying to feed that into it. So what I'm going to do is make sure that I know what I'm talking about. I'm going to call this function find val, right? And then I have to say def find val, and then it's gonna feed in. I'm just gonna call this CV. 2 spaces and say return CV dot split or CV dot split. I can put this up there too. So hopefully this works. Let me just see if this works and I'll open it back up. So maybe I didn't spell something right. Yep, exactly. Okay. I did capitalize that. Val. Apply. Okay. No, that's correct. Oh, no. Look, it got small again. Dang it. Make this one small. It got big again. I'm just gonna have to change the name totally. Maybe if and also if I save it. Conval is not an int, but all right. I don't know what it's doing. The only thing different is that I use pipes instead of underscores, which shouldn't be a problem. $3,501. Why does that become the value? 3501. See what I'm saying? This is the input. Okay, so I'm going to delete this kudzu for now. Just so that I can, yeah. Now it is running back and forth. See, that value is going. $3,309, $3,501. You guys see any patterns at all to that? That value is 3,261. So now there's underscores. Something I can think of. Percent comp value percent. I spelled something wrong. Comp value. Okay. Yeah. What's that? It shouldn't have to be. Oh, you mean like down here? Because we did change that before. this worked on my computer. All right. Looks like it's working. Sorry. Dot or make this now. It's going to be a long. Yep. Okay. That worked. Sorry, that was my fault. The problem was I forgot these plugs right here. So I should have brought it up before I tested it, but I didn't. So this was the problem. It needed quotes around it, and I'm not actually sure that it needs the strings around it, because the my version that I ran from, I didn't use these because it is a string already. So model, save model, run entire model. Yep. Okay. So bring that back up. The problem here is I don't know how many of you switched to underscores. Did any of you switch to underscores? What's that? Okay. Well, if you switch to underscores, change this to underscore. If you didn't, leave it a pipe. It should work. I just did that out of desperation because my version that I worked on before the lab, I made them underscores. I can actually change that back really fast. You saw how fast I changed it. Control F, replace. I'm going to change my underscores back to pipes, replace all. Save, close it. Now I can change this back to pipes. So everybody's will be the same, except for William, unless you change yours. This is the pipe, yeah. It's shift right above the enter. It just looks like a straight up and down line. All right. So I said, hey, it's going to be easy. It's just a single line of code. 15 minutes later. All right. But anyway, it is pretty easy. With code, lots of times, you make little errors, little bugs, and that's what I did. Sometimes it's frustrating. It makes you pull your hair out, but especially when you're standing up in front of an audience sweating it out. But if I just calmed down for a second, I could have seen my error, but it's quote %compval u %quote. Notice, like in the raster calculator, you always have the ability to like click the data set you want to use. You have to type it out and calculate values, so it's a little bit. It won't run. Try to run the whole thing.
Run that.
So what are you trying to run? You need to run this first. Run that. Pause. Now should be able to run that. Make it bigger. You can see the error. Python's case sensitive. You have comp value, you don't have a capitalized. You need to spell it out. No problem. Here's those This is the problem that it's having. I think. Okay, try it. Did you run the whole thing? Invalid expression. Go up. You have something more. It's precip underscore. All right. Okay, so what we need to do is just replicate this 2 more times, and we'll be all set. So I've got that, and now the output value says output value, so I need to rename this precip, and then I'm going to copy this and do it twice. 1, 2, and I'm going to rename precip. I'm going to rename this one temp. And I'm going to rename this one FFD. And then all I need to do is go into each of these, those 2. The one that says temp, you'll need to change it from 2 to 1. And then the one that says FFD, you'll need to change it from 2 to 0. And at that point, if you run the entire model, you should get a value for precipitation, temperature, and frost-free days that's correct. I'm going to go ahead and just, yeah. I'm going to go ahead and hit cancel. It's working because I can see these values. 8, 333, 135. 8, 300, 135. I'm a little bit worried because there's an extra parenthesis ahead of the value. 0, 0 is the first one. Yeah, the frost-free days doesn't seem to be working. Another error. Oh, I messed up. Hopefully you guys didn't make the same mistake I did, but I put an extra little quote in there. See that? That's the problem. Those are hard to see. Okay, so now I'm just going to hit cancel, see if it's working. 12, yep, 12, 127, 125. So I'm going to get all those different values each time through the loop. So now it's working. It's producing the long values that I need. So the final step here is to pull the kudzu calibration on, kudzu prediction onto there. And then feed in each one of these values. FFD goes in, that's going to be frost-free days min. Temperature goes in, that's going to be the temperature min. And precipitation is going to go in, that's going to be the precipitation min. So the way that this works is this iterates, creates these 3 values, and then it runs our model. It's going to run it 125 times. Okay? So that's a lot of times that it's going to run it. So what we can do, one thing that we need to do is change the output from, so that every time through the loop, it has a different value. Otherwise, the output tables will overwrite themselves. See what I'm saying? So we want this to be, we have a few different choices. One thing that we could do is just append the comp value onto the end of it. That might make the most sense. So it'll be ACC table with the comp value attached. So you'll see each of the three numbers. I'm going to do that. I'm actually going to add an underscore and then say percent comp value percent, and it is case sensitive. All these are case sensitive. So see that that's the value. Now the ACC table will be named. The first time through the loop, it'll be named like whatever the frost-free days minimum was underscore and each time. So I'm going to say okay. All right. Now we get to the one that I actually think is a little bit easier. If you read through the model only tools, remember I told you we're going to have to do collect values, right? So collect values, the way that it works is if you have a ton of different values that are output, it'll stack them all up once they're finally completed. It's kind of like it's outside the loop, and it will shove all of those into a collect values operation. So every time through the loop, we're going to create another table, and each table has one row in it. And the collect values tools is going to take all of those one row tables and merge them into a single table. I should have been more careful with my words there, right? Let's see if so now we need to come up with a tool that does that. Okay, in fact, it says it in the help here. This is another question that I asked. Should we use the merge, append, mosaic, cell statistics? Well, let's look at merge. I used the word merge. Was that the correct tool? Is that what we want? Yeah, merge takes multiple data sets and combines them. So is this what we want? Well, let's look at append, because I'll give you a hint. It's either merge or append.
I think it's a gift, because it doesn't overwrite anything, it just adds.
Appends multiple input data sets into an existing target data set, or, whoops, this one, merge, combines multiple input data sets of the same type into a single new output data set. Actually, we could use either one, but I'm thinking merge is going to work better, because if it's the other one, we have to kind of like finagle a way to say, okay, take the very first one and append everything onto there. Merge, what it does is it says, okay, here's all the data, push it into a brand new file. So let's do that one. We don't do it here. We actually get the merge tool, which is under data management, I think. Merge is actually on there, but where is it? Data management. Let's see where it might be. It's got to be in one of these ones. It's in general. Thanks. Merge. Throw it on there, and then we can output this data into merge. Those are going to be the input data sets, and we can call this one. We can call this data set ACC table final. That's what I'm going to call it. So it kind of like looks through and sees all the fields that are going to be possible. Because what if you tried to merge two different data sets with different fields? Then it would basically make a table with a bunch of extra fields, and so some would be missing. We don't have to worry about that because we already know that all our fields are going to be identical, right? All our fields are identical. So we don't need to change that part of it. I'm actually going to save this into the folder we've been working on. This one. All right, save. I'm going to lay this out. I like putting the iterator at the top. Save it again. Okay, so that's the model. So now let's see if it works for everybody, and we'll take like a little bit of time trying to see if it works. I'll also upload this in case you can't get it working. So now I'm going to say I'm actually going to run this from this way because I believe it causes less errors to run it from here. So now I'll run it, and hopefully it works. Let's see if it runs one time through the loop. No. Oh. So pipes are not valid characters for file names. Sorry. So it did matter. Okay. I can solve this problem easily. So the other option, because we don't really need, the file names don't need to be called with the %com value %. We can just call them, remember we have that variable n that I talked about before. And n is just the number of times that the iteration has been through. So if we change this from %com value %, and it's just this one here, the output of the kudzu model needs to be %n %. So here, I'll put them both up. Move this down. So now we're going to get an ACC table for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we would have to like go back into the Excel file and see, okay, that one was, this value. But the table itself actually stores all the values for us, so we don't really need you to do that. Let's just okay. Save it. Yeah. Oh, the merge part. So after the kudzu model, we collect the values. Did you do the collect? And then under the merge, all we did was have all the output of the collect is the merge. This collect right now is only showing one data set. That's because it failed on the first time through the last run. But it's fine. It's gonna work next time and fill those out. I hope it'll run. We may have to delete some of the temporary data that created because sometimes it has problems overwriting. ArcGIS is getting better and better at that though. Let's see. As soon as it runs through the model once, pretty sure it's going to work. Another thing about messing with models that are running is that lots of times if you attempt to look inside the database, it'll fail as it's running. Cannot open CTemp Lab 10 calibration. Oops. collect values. I wonder if we need at least one precondition over here so that it runs first. I'm not positive. And then we need merge. Where was merge again? Merge. Okay. Yep, we don't need the precondition, it looks like. Okay, yeah, it seems to be working now. So now it's going to run like 125 times. I'm going to go ahead and take the risk here real quick of our catalog. It might cause it to fail, but you'll get to see that it's working, and then I'll restart it, and then I'll help people that it's not working for them. So here's the data sets that we're working with. We're on lab 10 now. Lab 10. And we're inside calibration. Sometimes it's going to fail as soon as I open this up. Here's the, I guess I didn't know what I called it. Because I re-put merge on. So I don't know, maybe I can. I don't know what I merged it into. Sorry. But we can still see the individual tables. Maybe this is it? Let's see. But anyway, it is running, no, that's not it. It is running the module. I'm not sure where it's merging it, but you can see that it ran it there. That was the second time through the loop. Here's the third time through the loop. You can see what value is it changing. It's changing per SIP. So it changed it, and it got a little bit more accurate, and then it got even more accurate. Look at that. That's the fourth time through the loop. That's the fifth time through the loop. The sixth time through the loop, we're at 91%, and it's going to continue to go on like that. It looks like it's still running. So I'm going to let it keep running, and I'll help people. I just don't remember where I saved the final one. One of the things that's interesting to note is watch the model as it runs. It goes to kudzu, then it goes to collect, and then it goes to merge. Now, it's running merge every time through the loop. It's something that I don't like, but that's the way ArcGIS does it. The first time through the loop, it's merging just a single data set into the output. The second time through the loop, it's merging both of those data sets into the output. The third time, it's merging 3 data sets into the output. So I wish that it just wouldn't run that until it got up higher, but you have to live with it. So it's overriding this data set each time. It's kind of clunky. I mean, that's another reason why programming is often better, but it is running this now, and it's going to run through 125 times. It looks like right now we're on we're on 16 or 17. Look, the accuracy is going back down. That's not a very accurate area. Anyway, those aren't very accurate values. So, all right, I'm going to stop the video there.